Hello everyone, welcome to the tutorial on clampers with DC power supply. In the previous tutorial, we looked at clampers and we saw that it basically corresponds to the shift in the signal or the waveform to any desired level without changing the appearance. And we have seen that how we can clamp the signal in the positive direction or in the negative direction vertically, and the main three elements that we are going to be using are resistor, diode and capacitor. So this capacitor is going to be in series with the input, while the resistor and the diode would be connected in parallel with the output. So we also said that we can have a DC power supply. So let us analyze with the DC power supply. So just to recall what we did in the previous tutorial, so here if you observed, we have the input signal, we had the capacitor in series with the input, the diode and the resistor in parallel with the output. Depending upon the orientation of the diode, the signal was clamped positively or negatively. So if you would observe here, mainly the transition voltage was 0 volt. Now when we are going to have a DC power supply connected in series with the diode, the transition voltage will be corresponding to the DC power supply. So let us see that. So I will consider the first example. Now in this particular case, what I see is that I have connected a DC power supply in series with my diode. I have a capacitor in series with the input, resistor in parallel with the output. So since I have a DC power supply here, the output waveform will transition or get clamped depending upon my DC power supply. Since my input flows from positive to the negative, I need to first understand what is the polarity of my DC power supply. So if you see here, this is going to be plus and minus. So I can say that my transition voltage will be equal to plus 5 volt. So unlike the previous case where we had the transition voltage to be 0, now it is going to be plus 5 volt. So let me mark this on my input signal. Since plus 5 volt comes above 0, so let me mark this here. So this is plus 5 volt. Then we need to analyze in a similar manner like we had done previously. Always we need to analyze when the diode is forward biased first. So let me consider the case here. Looking at the orientation of my diode, I can say that my diode will be forward biased during the negative half cycle of the input. So it is this particular region when the diode is on, and above 5 volt the diode is going to be off. So case 1, when the diode is on, that is below plus 5 volt of my input signal, I can draw the equivalent circuit as in this manner. Since my diode is on and we are considering the diode to be ideal, that means the moment your input exceeds the 0th point, it is going to be on. So since the diode is ideal and there is no cutoff voltage related to this, so the moment it crosses, your anode potential crosses the cathode potential, diode is going to be on. So we are going to consider this to be the short circuit, because since the diode is on, this is 5 volt, and since we are giving the negative input, let me consider this as minus plus here of my input signal, and since the polarity is on the negative side, the polarity across my capacitor is also going to be minus plus. 1 microfarad is the value of the capacitor. Now I need to understand or apply KVL to determine the capacitor voltage. So let me apply. So this is going to be minus Vi plus Vc. The right hand polarity is minus Vi plus Vc minus Vout is equal to 0. Now if you observe, the output voltage is in parallel with the DC power supply. So our output voltage will be, Vout will be equal to 5 volt. So substituting that, I have the input which was given to be equal to, the peak value is minus 20. So this is going to be equal to minus 20 plus Vc minus 5 is equal to 0, or Vc is equal to 25 volt. Now we have determined the value of the capacitor voltage. Let us find out for the case 2 when the diode is off and determine what will be the output. Here we have known what is the output voltage, that is equal to 5 volt. For the case 2, when the diode is off, this condition occurs when the input is above 5 volt. So I'm going to be providing a positive input. Since the diode is off, it is going to be an open circuit, and when you are having an open circuit in series with the DC power supply, equivalently it is going to be an open circuit itself. So I'm not going to connect the DC power supply here because the equivalent circuit would be an open circuit. And then I have a resistor and I have the output voltage. Now you might be wondering that I didn't draw a resistance here, right? So since the voltage in the parallel circuit is the same, so when I draw a resistance in parallel also, the voltage developed across this resistance is also going to be equal to 5 volt itself. So whether I draw it or not, the output is not going to change. So here let me draw. And now, as we said in the previous tutorial, since the capacitor charged to the peak value of the input, the polarity of the capacitor is going to remain the same. So this is going to be minus plus itself. The voltage that was there is going to be Vc. Now we are giving a positive input, plus minus. The diode is open circuited. Let us apply KVL to this circuit now. So we have plus Vi plus Vc, because the polarity of this right hand polarity is positive, minus Vout is equal to 0. So the input that you are giving now, positive peak value is 10. So this is 10 volt plus Vc value is 25 minus Vout is equal to 0, or output voltage Vout is equal to 35 volts. So if I were to redraw the output waveform, I will have, during the positive half cycle, the peak value is 35, and during the negative half cycle, the peak value is 5. So this is 5 volt, this is 35 volt, the waveform for output voltage. So 0 to t by 2, the value is going to be 35, and t by 2 to t, the value is going to be equal to 5 volt. The peak to peak value of this particular waveform of the input side is going to be equal to 10 minus of minus 20, that is equal to 30 volt. And if you observe, the peak to peak value of this particular waveform is 35 minus of plus 5 is going to be 30 volt. So the peak to peak value of the input and the output is the same. So we have only shifted the waveform in the positive side, retaining the peak to peak value of the waveform. So hence we can say it has been clamped in the positive direction. Similarly, let us analyze one more example. So here if you observe, we have the waveform, but now the orientation of the diode is changed. The DC power supply that has been connected is in such a way that it is a positive DC power supply. So let me mark this on the input waveform. Again, this is going to be plus 5 volt. Now if you observe here, the diode is going to be turned on. If you look at the orientation of the diode, it is going to be turned on when the input is positive, because the anode will be at a higher potential than the cathode. So this is when the diode is on, while this is the region when the diode is going to be off. We always need to analyze for the case when the diode is on first. So let us do that quickly. Case 1, diode is on, that is above plus 5 volt. Whenever a DC power supply is connected, always you need to first check for the transition voltage, mark that onto the input waveform so that it becomes easier. So in this case, the transition voltage is plus 5. So that is why I said it is above plus 5 volt, because of the presence of the DC power supply. So above plus 5 volt, I am giving a positive value of the input. Let me redraw the circuit. I have a capacitor. Positive value of the input is provided. The diode is turned on, and I am considering an ideal diode, so it is going to be short circuited. I have the DC power supply which is connected, plus 5. Then I have a resistance, and I have the output voltage V out. So the voltage developed across these two parallel branches is going to be same. And we have connected the output across this resistance, which is nothing but you have connected it across the 5 volt itself. So just by looking at this part of the circuit, you can say that the output voltage is going to be plus 5 volt. Now how do I say that it is plus 5 is because this is positive, this is negative, and the polarity of my output voltage that is taken is also in sync with that of the output. So since this is positive, positive, negative, negative, that is why output is plus 5 volt. I need to compute the capacitor voltage. So for that, let me apply KVL to the circuit. I have plus Vi. The polarity of the capacitor voltage is going to be plus, minus, minus Vc, minus V out is equal to 0. The peak value of the input in the positive is 10 volt, minus Vc minus phi is equal to 0, or you can say Vc is equal to 5 volt. Now let us analyze for the case when the diode is off. That happens in the negative side. So during the negative side of the input, your capacitor is already charged to the peak value, so its polarity is going to remain the same. Negative input is applied. When the diode is off, it is going to be an open circuit. So whether you connect the DC power supply or no, the entire branch is going to be an open circuit. Then you have a resistance, and you have the output voltage. Let us apply KVL now. So this is minus Vi minus Vc minus V out is equal to 0. We are applying negative input, so this is minus 10 minus Vc minus V out is 0. Vc is nothing but 5 volts, so minus 10 minus 5 equal to V out, or I can say V out is equal to minus 15. So let me draw the output waveform. During the positive half cycle of the input, my output was plus 5 volt, that is to the point T by 2. During the negative half cycle of the input, my output is going to be equal to minus 15 volt, that is from T by 2 to T. If you see the peak to peak value of this is going to be 5 minus of minus 15, which is equal to 20 volt peak to peak. Similarly, if you see the peak to peak value of the input, this is going to be 10 minus of minus 10, which is equal to 20 volt peak to peak. So what we have done is we have retained the peak to peak amplitudes of the input at the output side. We have just clamped the signal in the negative direction. So we can have similar problems where the diode orientation might change accordingly whether it is forward bias in the positive or the negative direction will change. And we can even have a orientation of our DC power supply. Now in this particular case our DC power supply was plus minus. We can also have supply when it is connected in the reverse, and that way our output waveforms also will change.